fluid coding, and AI. Kimi K2.6 should not be judged like a prettier chatbot with a bigger benchmark table. Moonshot is pitching it as a workflow engine, long-horizon coding, multimodal input, tool use, and agent swarms. That changes the test. The question is not whether the launch page looks strong. The question is whether the work ends cleanly. For this episode, the benchmark is not the product. The product is the final state. If Kimi takes a bug ticket, we care about the diff and the tests. If it repairs a user interface, we care about before and after screenshots. If it runs a swarm, we care whether the final answer is more correct than a single careful agent, not whether the transcript got longer. That is the bar: completed work, review burden, and evidence. The official Kimi story is ambitious. Kimi K2.6 is described as an open-source model for coding, long-horizon execution, and agent swarm workflows. The API docs describe a 256,000 token context window, stronger long-term code writing stability, improved instruction compliance, self-correction, multimodal input, and thinking and non-thinking modes. The model card adds the scale, a 1 trillion parameter mixture of experts model with 32 billion active parameters and a vision encoder. That is not a small chatbot claim. It is a systems claim. The swarm claim is the loudest part. Moonshot says K2.6 can scale to 300 sub-agents and 4,000 coordinated steps, up from K2.5's claimed 100 sub-agents and 1,500 steps. The same post gives vendor-reported examples: a 12-hour Zig inference optimization case with more than 4,000 tool calls, a 13-hour Exchange core optimization case, and a 5-day internal infrastructure worklog. Those are interesting case studies. They are not a blank check. There is another reason to test the workflow, not just the model name. Open weights do not guarantee identical behavior everywhere. Moonshot's own vendor verifier post says provider implementations can diverge because of decoding, infrastructure, and tool call behavior. OpenRouter lists Kimi K2.6 as a route with a large context window and public pricing signals, but a third-party route is still a route. For agent work, the route matters because the tool calls, context handling, latency, and failure recovery are part of the product. The fairest evaluation rule comes from long-running agent work. Score the final state, not the path the agent happened to take. Anthropic says multi-agent research can beat a single-agent baseline in its internal research evaluation, but it also says these systems can use about 15 times more tokens than chat. It warns that most coding tasks are less parallelizable than research, so the swarm has to earn its cost. More agents only matter if they improve the checked result. The first ticket is a messy repo repair. Give Kimi a small real repository with failing tests, stale docs, and one ambiguous bug report. The success condition is boring on purpose. Did it read the relevant files before editing? Did it patch the smallest reasonable surface? Did the tests pass locally? Did it notice platform traps like dates, file paths, and shell differences? This is where long-horizon coding either becomes disciplined engineering or turns into a beautiful plan wrapped around a broken ticket. The second ticket is screenshot to interface repair. Start with an existing screen and a target screenshot. Ask for layout, spacing, interactive states, and responsive behavior to match the target without abandoning the local component system. This is a good test because a one-shot pretty screenshot is not enough. The interface has to survive desktop and mobile checks, hover states, overflow, typography, and build validation. For coding-driven design, the receipt is not taste. The receipt is comparison plus verification. The third ticket is a multi-file refactor. Change a shared API or schema across server code, client code, tests, and docs. The point is not to make the task huge. The point is to force dependency tracking. Which files should change? Which contracts must stay compatible? Did the model follow existing patterns or create duplicate helpers because it missed the local architecture? This is where code-based reading becomes the bottleneck. Generating code is the easy part. Changing the right code is the test. The fourth ticket is the fairest place for a swarm: parallel research plus code. Ask for a provider adapter with a compatibility matrix. One branch researches current provider docs, another checks model routing and pricing, another implements the adapter and tests. The final answer has to reconcile conflicts, cite sources, and make the code reflect the research constraints. If extra agents help anywhere, it should be here. The work naturally splits and the final synthesis can be checked. The local benchmark receipt in this workspace is useful, but only as a warning. It is not a Kimi K2.6 result. The available report is for an inferred open router Quen run. It scored 680 out of 2,172 overall, or 31.31% across 93 cases. Every listed case failed. Coding still earned partial credit, but non-coding categories scored 0. That is the final state gap in one file. Output can look busy while the evaluator still says the case failed. My practical verdict is this: Kimi K2.6 deserves an agent workflow test, not a leaderboard reaction. The strongest case is broad, parallel work, where independent agents can gather evidence, explore alternatives, and feed a real synthesis. The weaker case is tightly coupled coding, where shared context, review burden, and coordination overhead can erase the advantage. So the decision is operational. Use Kimi where the task can be decomposed and the receipts are checkable. Keep a tighter human-guided loop where correctness, security, or architecture depends on one coherent reading of the codebase. That is the useful Kimi K2.6 question, not how much it can generate, but how much verified work survives review. If this helped you think more clearly about agent workflows, like the video and subscribe to Fluid Coding and AI.